Okay, so today we're going to be doing a lesson in regards to a high school physics course. I will not get the chance to implement this in a classroom just yet, but today we're going to be focusing on mechanical energy, specifically potential and kinetic. Here we're just really gauging the background of it, so this is more of an introduction type lesson. So most of these students will have already known most of these terms. They should be familiar with them, just not necessarily the concrete details. Um, So here I have a reference slide. At any point, I tell students to kind of refer back to this if at any point they get lost. A lot of the slides are very self-inductive, and for the most part, for the people that I had go through them, they didn't have much troubles, but in case any student is struggling or they need to know the order, I included a reading of it. I'm not going to have it go through the whole thing, but you have that purpose. I also included the home slide, as you'll see with the next slide. That's more of the place that I want students to refer to because that's more in reference of the broad scape of all the activities. So technically either this home button or this star will guide the students, as I said. Basically, in here, I'm assuming that anytime that the students see this star on their presentation, they're informed to click it to continue on with the lesson. So here I have more of the definitions of mechanical energy, where it comes from, why we care about it, and then more specifically kinetic and potential energy. So here I have, this is representing potential energy. Students will recognize this because it's at the top of the hill, the velocity is at 0 meters per second, and then it'll roll down the hill, and as you can see here, so I'm gonna go ahead and click through here. I have more on potential energy. I give them the equations. I also want them to continue on, so we'll go ahead and look through some of the examples. So here we have two different types of kinetic energies, both represented through pictures. So here, let's go to the spring, and we'll talk about elastic potential energy. There's a reference. Come back here. Then we have the skydiver, who I have edited this 5 times, and this will not work. So I'm gonna have to go back and do that again. That's very frustrating. And then we'll go over here to kinetic energy, so the energy of movement. Here's all the equations, kind of more of a background, broad definition. Go ahead and click at the examples. We have electrical energy. Here we have thermal and heat energy. And then we have a broad mechanical energy. So I also included a short quiz on this. I'm going to go ahead and skip the verification. We'll come here. This isn't necessary to have gone through all the slides yet to complete this, not even all the examples. This is all information that they should know, but this will end up giving me a better idea of where they are at. I like to include how confident they are in their answers because sometimes I find students will be honest and say, I'm not very confident in this, even if they have the correct answer. And so that kind of gives me a good idea of where do we need to focus on just confidence-wise. So let's go back to where we were. Where are you? There you are. Okay. So then we'll go back to the examples. And then as here I say return to home, we'll come down here, and then this is where we'll continue on with the rest of the material after they know all the notes now. So here I have them go through a little video. It's very short, but it's more of just reiterating everything that I say. A lot of this material isn't necessarily difficult, but a lot of times it takes a lot of reiteration for students to really click with it. So after they watch through the video, they should be able to answer this question. They should be able to answer it because it says it word for word, so we'll see. I'm going to go ahead and click on the wrong answer, and I get a little whiplash sound effects reminding the students of the concept. Go back, and then we'll click the correct one, and they'll get a nice little applause. Each slide I have this little voice whenever there's a lot of text for students who need to hear it out loud. Anyways, going on, I have the star here, but I have it on a skateboard because you'll see here I'm going to have them go and work on an interactive lab. So they'll go here to get to the lab. They'll go through and do the lab. It's very easy. PhET is very fun. I tell them to do friction. They'll play around with it, right? So we have the little skateboarder. There he goes. You can make him bigger. You can make there less friction. Super fun. So then when they continue on, they'll get the worksheet in which this has the guided questions to complete the activity. So they'll go through. A lot of this is just playing around with it, kind of figuring out what they need to do, getting more comfortable with friction and potential and kinetic energy. So then we'll continue on. This is more of a reference slide to them for their notes. So I have a compilation of all the equations that we had used in the slides, any ones that'll benefit them more in the future. This is a broad kinetic energy plus potential energy is going to give us that total mechanical energy of the system. Just reiterating this once again. And I have the definitions of all the answers. Continue on, a little bit more equations. These are less important, but still good for them to have in their notes. So I want to make sure that I have that somewhere for them. And then here I have some more pictures associating with the different types of energies. Again, reiterating that potential energy and kinetic energy are two different things, and they all have different forces that come out of it. And then I have an exit ticket. This is an invite to the Google Classroom in case any student isn't already in it. But then here we have a link to the actual question the students are asked to answer. So this is give an example of a system that undergoes a change in potential energy to kinetic. So they wouldn't necessarily not be able to answer this without the lesson, but hopefully we can get some better examples after they finish this interactive lesson. And then there you have it.